The space shuttle. It was part rocket, part airplane, part orbital science lab, all rolled into one. But how on earth did this incredibly complex machine actually work? Well, to figure that out, we're going to follow one of its most daring missions, from the chaos of the launch pad to the calm of the runway. So, picture this. It's 1992. The brand new Space Shuttle Endeavour is on a high-stakes rescue mission. A multi-million-dollar satellite is just tumbling, completely useless in the wrong orbit. And as astronaut Bruce Melnick said, this thing was never, ever designed to be handled by people. And to save it, they had to fly what was, without a doubt, the most complex and, at times, the most dangerous machine ever built. This is the story of how that machine actually worked. We're going to follow this one mission, from the fury of launch all the way to landing. All right, first up, the fury of the launch. And look, this wasn't just some push a button and go situation. We're talking about a symphony of controlled violence, timed down to the millisecond. It all happens so fast. At T-minus 6.6 seconds, the three main engines fire up. They generate so much thrust that they actually bend the entire shuttle stack forward. It's a move NASA called the twang. And only when the whole thing springs back to being perfectly vertical, boom, the solid rocket boosters ignite, explosive bolts fire, and the shuttle is unleashed. And when I say unleashed, I mean it. Each of those two solid rocket boosters, or SRBs, kicked out a staggering 13,000 kilonewtons of thrust. To put that in perspective, these were, and still are, the most powerful solid rockets we've ever strapped humans to. So where's all that oomph coming from? Well, it's not liquid fuel. It's this solid, kind of rubbery mix of aluminum powder and an oxidizer. Basically, they packed it all into the casing like a giant firework. And the thing about fireworks, once you light them, you can't turn them off. There's no going back. Just 45 seconds later, bam, they go supersonic. And this is wild. The deafening roar of the engines actually gets left behind them. All the crew hears now, according to Bruce Melnick, is the sound of the air screaming past the windows, which he said sounds just like a train howling through a tunnel. Okay, 2 minutes in and the boosters are spent. Time to ditch them. But this isn't some gentle uncoupling. We're talking explosive bolts and small rockets firing to push the boosters away. It was so violent, Melnick said it was just a big bang and a fireball. So intense, he thought for a split second, did we just explode? So after that insane bone-rattling ride from the boosters, suddenly everything gets super smooth, like eerily smooth. The astronauts had a great name for it, electric drive, because now it's just the three main engines, quietly and efficiently pushing them the rest of the way into orbit. About 8.5 minutes after liftoff, silence. The main engines cut out. And in that one instant, everything changes. The crushing force of being pushed to orbit is just gone. The crew lurches forward against their straps, and just like that, they're weightless. They're in space. And then, of course, there's the view. You can train for years, but nothing prepares you for that. In fact, Bruce Melnick was so completely mesmerized seeing Earth for the first time, he totally blanked on his very first assignment. He was supposed to snap a picture of the external tank as it fell away. As he put it himself, I was so blown away, I choked on my first job. So you're in orbit. How do you, move? The shuttle had this whole network of 44 little thrusters, and they use this really unique stuff called hypergolic fuel. The magic here is that the fuel and the oxidizer just burst into flame the second they touch each other. No spark plug needed. It's super toxic stuff, sure, but it's also incredibly reliable, which is exactly what you want for those tiny, precise movements in space. And this brings us right back to that stranded satellite. For 2 days, they tried and failed to snag it. So they cooked up this wild, totally off-the-books plan. A 3-person spacewalk. This had never been done. The shuttle wasn't even built for it. The idea? 2 astronauts would literally just grab the satellite with their hands, while a third floated over to attach the capture bar. Absolutely incredible. And how could they even pull off something that crazy? Well, it all came down to the Canadarm. And this thing is a total engineering marvel. Get this. Here on Earth, this 15-meter arm is so flimsy it can't even support its own weight. But in space, it becomes a beast, strong enough to move 30 tons. It was designed for one place and one place only, orbit. Okay, so mission accomplished. The satellite is saved. But now comes the really hard part, getting home. And that means a trial by fire, literally, re-entry. And this is a heck of a physics problem. The shuttle's frame is made of lightweight aluminum, right? but re-entry temperatures can hit over 1,600 degrees Celsius. So the big question for the engineers was, how do you stop an aluminum spacecraft from just melting as it screams back to Earth? And this really puts the problem into perspective. Aluminum starts to melt at just 177 degrees Celsius. Re-entry is nearly 10 times hotter than that. By all rights, the shuttle shouldn't just melt, it should completely vaporize on the way down. So, what was the genius solution? The thermal protection system. And it wasn't just one big heat shield. Think of it more like a giant complex puzzle with over 32,000 unique pieces. You had the super tough carbon material on the nose and wings, the hottest spots. Then all those iconic black tiles on the belly, designed to glow red hot and radiate that heat back into space. And the white tiles on top, their job was just to reflect sunlight in orbit. Every single tile was critical. So as the shuttle hits the atmosphere, and I mean hits it, at 30 times the speed of sound, it wraps itself in a bubble of glowing plasma. And this plasma cloud is so intense, it blocks all radio signals. For 12 solid minutes, there's just silence. Radio blackout. The crew is utterly alone up there. Okay, they've survived the inferno. They're through the worst of it. But the shuttle has one last incredible trick up its sleeve. It has to land on a runway like an airplane, except for one tiny, terrifying detail. It has no engines. It's a 100-ton glider. Yeah, they used to call it the flying brick, and you can see why. A normal airliner comes in on a gentle 3-degree slope. The shuttle, it was a 20-degree nosedive, coming in hot. And because it's a glider, there's no pulling up and trying again, no go-around. The commander has one shot, and only one shot, to get it right. So this whole final approach is just this beautiful, high-stakes ballet. The commander flies the shuttle through these big, sweeping turns to scrub off speed. Then they line up with the runway, drop the landing gear at the last possible moment, pull the nose up to flare, and touchdown. And even then, they need a drag chute just to help them stop. And with that, STS-49 touches down. That landing marks the end of one of the wildest, most audacious rescue missions we've ever seen. It was just a perfect showcase of the crew's ingenuity and the shuttle's unbelievable capabilities. So what's the legacy here? I mean, the shuttle program gave us incredible triumphs, right? It built the space station, it saved the Hubble telescope, but it also brought us absolute heartbreaking tragedy. It was a machine that was constantly pushing the very edge of what was possible. So was it an irreplaceable engineering marvel or a brilliant but deeply flawed machine? I think the real answer is it was both.